So we're going to take a look at section 5.3, and this is where we really get into how we use these different angles and how we take these angles we talked about, we gave some definitions to them. Now we're going to put it together and we're going to work our way up to something called the unit circle. And we'll put all this together as the week goes on in class, but I want to start off with a quick definition of what we mean by the unit circle. So unit circle is exactly like it sounds. It's a circle, it's a circle that has, so with a radius of 1 unit, which is why it's called the unit circle. So it's basically, picture a circle where the radius is exactly 1 unit. The equation of the unit circle, you may just kind of remember the general equation of a circle. The unit circle, we always just center it at the origin, because remember, the angle in standard position has its vertex at the origin. So a general equation for a circle centered at the origin is x squared plus y squared equals r squared, where r is the radius. But if we're talking about a unit circle, since the radius is 1, it becomes x squared plus y squared equals 1. Okay? So let's put some of this together. It says, so we're looking at the definitions of the 6 trigonometric functions. There are 6 trig functions that we're going to use over and over and again for the rest of the semester. And this is kind of where they come from. This is the definition. So it says, let t be an angle in standard position, and let p of t equals xy be a terminal point on the circle associated with the angle. It sounds more complicated than it is. So we have our unit circle. We have a point on the circle located at x comma y. If r equals x squared plus y squared, square root of x squared plus y squared is the distance from the origin out to that point, then the 6 trigonometric functions of t are defined as follows. If this is a little blurry to you at this point, hang tight. Don't worry about all the details just yet. Just go with me for a second. Let's just get these basic definitions. The cosine of t is always defined as x. So whatever x is on the circle, actually, hold on. Let's do it this way. It's going to always be, let's be a little more general about it. It's always going to be x over r, whatever r is. Sine of t is always going to be defined as y over r. I don't know why there's this extra box here. Well, let me do it this way. Y over r. Pay attention to where I'm putting everything. Okay. And then tangent of t is going to be defined as y over x. So these are sort of the 3 foundational functions that we're going to work with: cosine, sine, and tangent. It's always cosine of the angle. So cosine of t, if t is the angle, is defined as x over r. Sine of t is y over r, and tangent of t is y over x. Now, these other 3 along the bottom, these are called the reciprocal functions of the ones above. So this one, SEC, we would actually, the word written out is called secant. And so the secant of t, since it's the reciprocal of cosine. So think about what reciprocal means. Reciprocal is where you flip, right? You flip the ratio. So if the cosine is x over r, secant is going to be r over x. CSC stands for cosecant, the cosecant function. So cosecant is going to be the reciprocal of the sine function, so that is r over y. And then COT stands for cotangent. And there's lots and lots of relationships between these different trig functions, but these are the reciprocal relationships. Cotangent is reciprocal of tangent. So therefore, if tangent is y over x, cotangent is going to be x over y. And those definitions will always hold. So let's do an example. It says if the point on the circle that we're interested in, so this point xy, is given by these 2 fractions, so the x-coordinate is -1/2, the y-coordinate is radical 3 over 2. If this is a point on the unit circle that corresponds to some angle t, I don't know what the angle is. I don't need to know the angle right now. I just need to know that it intersects the circle at this location, okay? -1/2, comma root 3 over 2. Find the values of the 6 trig functions at angle, or of angle t. Use the definitions above. It says draw a triangle here. I took this out because we haven't really got into how this relates to a triangle yet. We'll get into that later, so I'm not going to worry about the triangles right now. Let's just use the definitions on the unit circle at angle t. If we are using a unit circle, so here's the idea. This is x, and this is y. What is the r value if we're using a unit circle? Remember, r, when you talk about a unit circle, r is going to be 1 because the radius is 1 unit. So the r value we're going to work with is 1, okay? So let's kind of put this together. Let's start with cosine. Cosine of angle t, according to the chart up here, is x over r. So it's going to just be x, which is negative 1/2, over r, which we just said is 1. So that just simplifies to negative 1/2. Sine of t is going to be y over r. So y is going to be this coordinate right here. So that's root 3 over 2 over r, which you just said is 1. So that simplifies to root 3 over 2. Tangent is going to be, according to the chart, tangent is y over x. So that means I'm going to take the y coordinate back here. So root 3 over 2, I'm going to put it over the x coordinate, which is negative 1/2. Remember how to simplify a complex fraction. You take the second fraction and you flip it and use the reciprocal. So we have root 3 over 2 times the reciprocal, negative 2 over 1. Notice those 2's will cancel out, and I'm left with negative radical 3. So there's the 3 values right there. There's the cosine value, there's the sine value, and there's the tangent value. I'm going to skip the other 3 right now. I want to focus on sine and cosine actually in this section. So I'm going to skip the other 3, secant, cosecant, cotangent right now. I just want to make sure we get the basics down. So here's cosine, sine, and tangent. All right, then it says, example 2, consider the angle on the unit circle at pi over 2. Let's make a sketch of this first of all. So pi over 2 radians would appear where? Let's think about that for a second. So we start out on the positive x-axis. Don't forget. Let's make that a little neater. Start out on the positive x-axis, and we rotate, since it's a positive angle, pi over 2, I'm going to rotate counterclockwise. Remember, this angle over here is 180 degrees, which is also pi. So pi over 2 would have to be half of that, right? Half of the distance to pi. So pi over 2 is actually the angle up here. So I'm going to rotate this way, and my angle is going to stop up here somewhere. All right, so this is my angle. So pi over, sorry, it's a little messy. Pi over 2 is actually a right angle. In degrees, it would be equivalent to 90 degrees. I don't want you to worry about the degrees. I want you to focus on the radian measure because that's the more important relationship right now. Think about what point this would be on the unit circle. So here's the idea. The unit circle goes like this. Oh, this is a terrible drawing. Sorry about that. Pretend we have a circle that goes around the origin. The radius is 1 unit. So this distance from the origin to where I stop to draw this angle is exactly 1 unit. And you're on the y-axis. So think about if I'm on the y-axis and I go up a distance of 1 unit, what is the ordered pair that corresponds to that point? Well, the x value, because I'm on the y-axis, would be 0, wouldn't it? There's no x value. I'm on the y-axis. That would be 0. The y value, however, because I went up a distance of exactly 1 unit, because that's the radius of the circle, is going to just be 1. So the point here, the moral of the story, is that this corresponds to the point 0, 1 on the unit circle. And that's what you want to focus on. So let's go back up to our chart here. And by the way, the radius for this, because we're using a unit circle, the radius is 1, right? Remember that, the radius is 1. So according to the chart, cosine is going to be x over r. So let's write that down. So cosine of that angle is, and actually, they said t is pi over 2. So I'm going to actually use the pi over 2. So cosine of pi over 2 is equal to x over r, which is going to be x, which is 0, over r, which was 1, which just gives me a cosine value of 0. Let's do sine. So sine of pi over 2, according to the chart up here, sine is y over r. So let's write that down, y over r. So that means that my y value is 1. My radius is 1 as well. So my sine of pi over 2 value is equal to 1. Finally, tangent, I'm going to skip the other 3 for now. I'm just going to do these 3 again. So tangent of pi over 2 is, according to the chart, equal to y over x. So that means I'm going to take the y value and put it over the x value. So 1 over 0, which gives me, since I can't have 0 in the denominator, we would say that that is undefined. Okay, so let's just do those 3 for right now. I'm going to skip the details on the others. Okay, let's do the same thing. Let's find the sine, cosine, and tangent values for pi over 4. Okay, so for pi over 4, let's figure out where that is, first of all. So think about what we just said a minute ago. If this is pi over 2, we only want to go 1/4 of a pi. So that would put me in the first quadrant exactly halfway through. Start out on the positive x-axis. Remember, this is pi over 2 up here. This is pi over here. I only want to go 1/4 of a pi. So really start thinking about distances when you draw these radian measures. 1/4 of a pi just puts me into the first quadrant. All right? So this would be my angle, pi over 4. Now, where is the point on the unit circle that I'm going to work with? So remember, this is like your circle. It goes all the way around here. This is the arc that's cut off. Okay? So remember the distance from here to here, because it's a unit circle, the distance is 1 unit. And so let's see, let's think of a good way to do this. Remember that the equation for the circle was x squared plus y squared equals 1. Keep that in mind. So x squared plus y squared equals 1. And so what's going on here is the point on the circle, the x comma y value that's on the circle, because we're at an angle that's pi over 4, that's exactly halfway into the first quadrant. I'm trying to think of a good way to explain this since we haven't done the triangles yet. But since we're in the first quadrant, I'll tell you what, for now, just take my word for it, that x and y are going to be the same. So if my radius is 1 and x and y are the same, think about it this way. How could I get the x and y value if the radius is 1 and x and y are the same? I'm going to just call that, well, let me use a different variable. Let's call it a squared plus a squared for right now. So x and y are the same. So I'm going to say a squared plus a squared, of course, is 2a squared. Solve for a here. Divide by 2. I get a squared equals 1 over 2. Take the square root. Remember, when you take a square root, technically you need plus minus, right? However, I'm in the first quadrant, so we're only dealing with positive values for x and y. So I'm just going to use the positive square root of 1 over 2. If we simplify that, that gives me 1 over the square root of 2. Normally I say don't worry about rationalizing denominators. However, it's going to be easier if we just recognize this, how it's more commonly going to be seen. So I'm going to rationalize by multiplying by radical 2 over 2, which is root 2 over 2. Okay? If this was a little bit of a whirlwind for you at this point, do not worry about it. Focus on the value that I'm going to use and then how we get the sine, cosine, and tangents, because that's really the important thing for this lesson. So here's the idea. Here's the idea. X and y we said were the same. The value for both of those is this root 2 over 2 that I just came up with. So the ordered pair that I'm going to work with is going to be radical 2 over 2, comma, radical 2 over 2. So this is x, this is y. Let's put it together and let's do our sine, cosine, and tangent. I'm going to start with cosine just because I had that in the chart earlier. So the cosine of pi over 4 is going to be equal to equal to x over r. And by the way, I hope you're noticing by now a little pattern. If r is 1, cosine just becomes x, right? If I'm dealing with a unit circle, r is 1. Cosine is x over r, but r is 1, so cosine just becomes x. So this x over r, since r is 1, just becomes, really it just becomes x, right? Because remember, r is 1. Don't forget that. So the x value is radical 2 over 2. The sine value, sine of pi over 4, according to the chart back here, sine is y over r. Again, same thing. R is just 1 because I'm on the unit circle. So this becomes y over r, which just becomes y since r is 1. And the y value was the same thing. It's radical 2 over 2. The reason the x and y are the same is because this comes from what's called a 45-45-90 triangle. And you may or may not remember from high school geometry. And if you don't remember, it's okay. But a 45-45-90 triangle, the legs of the triangle were exactly the same, which means this x and y value are going to end up being the same thing. We'll get more into that later in the course. Don't worry about it. For now, just take my word that it's root 2 over 2 for both of these at the location pi over 4. That's the important thing. All right, finally, let's do tangent. So tangent of pi over 4. So according to the chart, tangent is y over x. So tangent of pi over 4 is y over x. So y was radical 2 over 2. x was also radical 2 over 2. So if I take radical 2 over 2 or radical 2 over 2, the same value, that reduces to 1. So my cosine value is here, my sine value is here, and my tangent value is here. All right? Okay, so let's just kind of summarize this. I'm not going to go through this little process for every single one of these. Here's the big picture. There are special angles that are going to come up over and over again on the unit circle, and we're going to use these repeatedly for the rest of the semester. So pretty quickly, you're going to want to remember these. The more we do, the easier it'll be to remember these. But what I want you to remember is that when you're dealing with the unit circle, the radius is 1. The point on the circle, x comma y, if the radius is 1, cosine just becomes the x coordinate. Sine just becomes the y coordinate, and tangent will always be y over x, okay? So with that in mind, I'm going to give you these special angles on the unit circle. Pi over 4 is the one we just did. There's the x and the y values, radical 2 over 2 for both of them. So let's fill those in because we have them. The cosine value, we said, is going to be radical 2 over 2. The sine value, we said, was radical 2 over 2. And the tangent value, remember, was y over x, which ended up being 1. Okay? Let's go back up here and pick up 0. So 0 would correspond to, so the angle 0 would literally be this point right here on the unit circle. That's on the positive x-axis, so that would correspond to the point 1, comma 0. And so that's what they're showing you here. 1, comma 0 would be the point on the x-axis. Okay? So the cosine value there would be 1. The sine value there would be 0. The tangent value, think about that. It'd be 0 divided by 1, right? 0 divided by 1 would just be 0. Let's look at pi over 6, which is equivalent to 30 degrees in degree measure, but I want you to focus on the radians because that's what we're going to use most of the time. Pi over 6, the cosine value, so here's your values, root 3 over 2 and 1/2. The cosine value there would be root 3 over 2. The sine value there would be 1/2. Now, the tangent's a little bit more complicated to figure out. It's y over x. Let me do it on the side here. It's going to be the y value, which is 1/2, over root 3 over 2. The 2's, if I flip this, are going to cancel, and I'm just left with 1 over root 3. And if I rationalize that, that gives me radical 3 over 3. Okay? Pi over 3, notice what pi over 3 does. It takes the values you had at pi over 6 and they reverse position basically. So x is now 1/2 and y is root 3 over 2. See how those switch? So your cosine value there is 1/2. Your sine value there is root 3 over 2. All right, tangent, it's going to be y over x. So if we work out the math here, root 3 over 2 over 1/2, the 2's cancel. And I'm just left with radical 3 over 1, which is just radical 3. Okay? And then we'll do these others. Pi over 2, we did that earlier. Pi over 2, we had, where was it? In this example, the point on the circle at pi over 2 was 0, comma 1. So there it is again, 0, comma 1. The cosine value then would be 0. The sine value there would be 1. Tangent value, remember, 1 divided by 0, we said was undefined. Pi at angle pi, so that would be on your unit circle. Think about that. Angle pi would be over here. So the point on the circle there would be -1, comma 0 because you're on the negative side of the x-axis. That should make sense to you, right? If this is the edge of my circle goes like this, right? This distance is 1 unit, but you're on the negative side. So the x value is -1. That's your cosine value. The sine value is 0. The tangent value would be sine divided by cosine. So that'd be, same thing, y divided by x, which would be 0 divided by -1, which is 0. 3 pi over 2, where is that? First of all, 3 pi over 2 is down here. So down on the negative side of the y-axis, your points switch to 0, comma -1. So your cosine value there is 0. Your sine value is -1. Your tangent value would be what? Think about it. It'd be y divided by x. So if I have -1 divided by 0, again, that would be undefined. Finally, 2 pi is the exact same thing as 0. It takes you back to where you started. So notice that your values start to repeat. Every time we do these coterminal angles around the circle, these values are going to repeat. So if I'm back at 2 pi, I'm back at 1 comma 0. So my cosine value is back to 1, my sine value is back to 0, and my tangent value, y divided by x, would be 0 again. All right? Do not lose this chart. Keep track of this because we're going to use this quite a bit over the next few days. Okay, then it says, use the table and symmetry on the unit circle to find the following angles. All right, let's draw a little picture here. Cosine of negative pi over 3. First of all, where is that angle? Let's do this. Let's start with cosine of pi over 3. Where would a third of a pi be? A third of a pi would be in the first quadrant again. Remember, this is a half pi up here. So a third of a pi would be in the positive direction, would be in the first quadrant, maybe about right there. A third of a pi. So there's pi over 3. Negative pi over 3 means I'm going to go that same exact distance, but in the other direction. So that means it's going to be symmetric down here. So negative pi over 3 would be this angle right here. So in the first quadrant, what is the x and y value on the circle there? Go back to your chart. Pi over 3 is right here. The x and y value there are 1/2 comma radical 3 over 2. That's from right here, up here. So think about the symmetry of the graph. If I'm down here, really think about what's positive and negative in each quadrant. If I'm in the fourth quadrant, my x values stay positive, don't they? I'm in the fourth quadrant, my x values stay positive. So this value would be 1/2 again, but my y value will become what? If I'm in the fourth quadrant, I flip down here, my y value becomes negative, okay? So it says to find the cosine value there. Well, cosine, of course, remember, is the x coordinate. So the cosine value would be the x coordinate at that location, which would be positive 1/2. Now, I could have asked you, I didn't. Let's just try it. What if I had said sine of that angle, negative pi over 3? So sine value would have been the y value at that location, which would have been negative radical 3 over 2. Oops, radical 3 over 2. There it is. Okay, so sine value would have been the same quantity, root 3 over 2, but it's negative because this angle is in the fourth quadrant. Let's try negative pi over 4. Think about where that would end up. All right, let's see. I always relate it to the positive angle. So positive pi over 4, remember we said earlier, positive pi over 4 is halfway into the first quadrant. There's positive pi over 4. Negative pi over 4 would be the mirror image going the other way. This would be negative pi over 4. So let's go back up here. Pi over 4, our values were radical 2 over 2 for both x and y. So up here, the ordered pair would be radical 2 over 2. So if I'm in the fourth quadrant, what are my values going to be this time? What is the pattern? It's all about patterns. The x value is still positive. So radical 2 over 2, that does not change. The y value, on the other hand, becomes negative. So this is going to be negative radical 2 over 2. Make sure you see why the y value becomes negative, because I'm in the fourth quadrant. Y's are negative in the fourth quadrant. Remember that? First quadrant, everything's positive. Second quadrant, x's are negative, but y's are positive. Third quadrant, both x and y are negative. Fourth quadrant, x's are positive, but y's are negative. That's where I'm getting that from. So my tangent value down there would be y over x. So it'd be negative radical 2 over 2 over positive radical 2 over 2. And so, of course, those values are the same, which gives me 1. The only difference is this negative gives me a negative. So the tangent in that quadrant is going to be negative 1 at pi over 4. All right, I'm going to stop there for a minute. I want you to take a break, and then I want you to come back and look at the second half of today's lesson.